My name's mRNA, and I have two sisters, but if we're being honest, I'm the family favorite. I'm the only one that got into Translation University, where I'm going to help fulfill the central dogma by helping translate protein molecules. As a eukaryotic mRNA, I have to leave home, the nucleus, to travel to the cytoplasm, where the ribosomes are located. But I'm scared, and I'm technically still pre-mRNA, so before moving to Translation University, there are a few things I need to do. First, I need my 5' cap, which I'll put on with a capping enzyme. This trusty cap will help me bind to ribosomes and fight off exonucleases, degrading college bullies. This is kind of weird, but I also need my poly-A tail. I need it to leave the nucleus to go to the cytoplasm. It will also help me fight degradation and will help me maintain my stability as I work to translate proteins. The poly-A tail is added when transcription extends past the poly-A site. Then CPSF and CSCF bind to each other, forming a loop. CF1 and CF2 bind to the RNA and cleave it. Then poly-A polymerase adds A nucleotides to the 3' end. But I'm not mature enough for Translation University just yet. I gotta cut off my introns. They're not needed, and I've been meaning to get a new haircut. My introns are removed and my exons are joined in this process called mRNA splicing. Pre-mRNA is cleaved at the 5' splice junction, and the end loops back to a site upstream the 3' splice junction. Cleavage then releases the lariat-shaped intron. The exons that flanked it are spliced together. This all occurs in spliceosomes made up of the SNRPs U1, U2, U4, U5, and U6. Now that I've completed everything on my list, I feel mature and I'm ready to go to Translation University to help translate proteins. Clearly, I'm the best RNA.
Hey! My name is Transfer RNA, and even though I'm not translated like my sister, I definitely have more friends than her, and I'm just as important. I'm literally bound to my best friends, the amino acids. I literally feel charged with them through amino acylation. Amino acids are attached to me using this specific enzyme called amino acyl tRNA synthetase, which correlates to certain amino acids. First, the amino acid and ATP bind to the specific enzyme. The enzyme catalyzes a reaction hydrolyzing ATP to AMP, forming amino acyl AMP. Then uncharged tRNA binds to the enzyme, transferring the amino acid from the amino acyl AMP to the tRNA. This forms me, amino acyl tRNA. Some fun facts about me are that I will always have the sequence 5' CCA3' at my 3' end. I'm around 75 to 90 nucleotides long and can shapeshift into a cloverleaf model. Even though I don't attend Translation University full-time, I spend most of my time here to help my sister out. I bring amino acids through the ribosomes to be added to polypeptide chains. I'm so close to my sister that my anticodon pairs with her complementary codon. We're also more alike than you think. I also go through processing as a pre-tRNA molecule and sometimes have introns too.
Hi, my name is rRNA, and I'm actually the oldest sister. I don't spend as much time with them one-on-one, but we're constantly around each other. I'm not a student at Translation University, but I work maintenance, and I'm integral to the function of ribosomes. Eukaryotic ribosomes have 4 rRNA molecules, 28S, 5.8S, 5S in the large subunit, and 18S in the small subunit. I also had to undergo processing as a pre-RNA, with ribonucleases removing the spacers. This results in the formation of functional ribosomal subunits. At the end of the day, all 3 of us are pretty different, but important in our own ways, and we're so excited to be powering life as RNAs.